Hi guys. I don't know why it's doing this. Anyway, back on the TV. My camera's being funny. But anyway, that's what I was talking about. Uh, so we're back on this. I'll show you some of the work I've done on it. I've been doing some recapping and stuff, and I'll show you that in a minute. But first things first. In the last video, I asked a question about a switch. It's on the power switch that when you shut the power off, it effectively what it does is ground the cathode, or take it to the ground, the cathode to ground that's on the picture tube. So I asked why they would do that, and two people I answered in the comments, and they are absolutely correct. It is to eliminate the afterglow, or the dot that shows up on the picture tube after you shut the TV off. Without that, when you shut the TV off, the screen will shrink down to basically a dot. And if it's like a brand new picture tube, a really strong picture tube, that can stay there for quite some time. It'll take quite a while, several seconds, for it to dissipate. Was not a big problem with the smaller picture tubes because the high voltage anode voltage was low relatively. But once the anode voltage, it seemed, with the bigger picture tubes, got upwards of 12,000 or more volts, this seemed to start causing the possibility of burn on the phosphor. So some of the companies started coming up with ways to eliminate that, and Stromberg Carlson came up with the idea to just ground the cathode when you shut the TV off, and that will give a path for the electrons on the cathode to flow out of from the cathode instead of being shot forward. So anyway, when the TV's done, we're going to see how well that works. So, what have I done so far? Well, let me kind of move some things around here. And basically, I'd started down in this area here. Well, of course, I had the high voltage out. But let me kind of zoom this in a little bit. Turn it down. Alright. And find a pointer. I had two resistors here. This one and this one here. They were out of tolerance, so I went ahead and replaced those two. There's two lime filter caps in here, going off each side of the line, coming in, so to ground. This is one of them I replaced. The other one is further up in a different location. In fact, it is right there. I haven't got it replaced yet. Let's see. So after I moved from that area, this electrolytic's loose. I had to order some more caps. I didn't realize I was getting that low. So I got an order into Mauser for a bunch of electrolytics for this set. And when it comes in, I'll restuff this one, but it sits right down in here. I had to move it out of the way so I could get these caps replaced. There's a couple resistors here I replaced, and their cap here. The rest of these are fine. Power resistor, the 5-watt power resistor that was here, I replaced it. And show you what happens to a resistor, that power resistors, when they burn out, because literally they draw too much current's going through them. If you kind of see the little ripple in here, this should be smooth basically through here, but there's a ripple. That's a coating. Surprisingly, most of the numbers stayed. The 1 is off of here, but that's just a line right there, but it should be 1250, and the 1 seemed to disappear, but the rest of the number actually stayed on there. I did a little math on this. What had happened is where that's at in the circuit, and I'll see if I can get the schematic up here and we can look at it kind of quickly. Yeah, adjust this down a little bit. We'll try to zoom in on this. Focus. Alright. Give me a second. That'd be nice. Okay. Here's that resistor. It's 315 volts on one side. And it comes up and it feeds up through the primarily the audio output transformer. And then that feeds up through a 68 ohm resistor into the plate. But on this side here, I've got a filter cap. 10 microfarad, 450 volt, goes to ground. That cap had shorted. And when it did, basically all the juice, all the current would go up through this resistor, through here, back through here, and down, back to ground, return back. Well, if you actually do the math, that works out to be about 250 or 280 milliamps going through that resistor then at that point. And I squared R, you square that and then times the resistance, and it works out to be about like 79 watts or 74 watts or something on a 5-watt resistor. So no wonder it bubbled up and burned out. Back up. Okay, so that's was in one of these cans here. I've already took them out and took them apart and unstuffed them. When the caps get here, I'll be restuffing them. I wanted to show you what a typical one looked like. Flaking off, falling off. You can see where it is as dried out as it gets, and then it was starting to, it is basically shortened through. These are places that went all the way through the paper, and we started shortening. That's why this is all just really torn up and disintegrated and stuff. And the interesting thing is, I don't know if I can get close enough. I'll hold it steady. But if you look right here, and it's probably not going to be too good on the camera, I can just get in there a little closer. It's literally corroded off. In fact, this one actually held for a little bit, but it broke loose. These were the two sections that come out and go out to the outside world, the positives. And this literally just corroded off. Because what happens with this, when the electrolyte breaks down, it basically turns into a full-fledged acid, and it will just it'll eat away at that aluminum. But this is just dry. It is just dry as all get out. So anyway, I'll be getting them rebuilt once the caps come in. I also replaced a couple caps here and a resistor, 2 resistors. This is the audio output tube, and this is the cathode resistor on it for biasing. These guys yet to be rebuilt. I cut that resistor loose and checked it, and it was way out of tolerance, as I suspected. And these are definitely leaky without even using the ICO. I can plug the digital multimeter on there, the Fluke, and it reads about 3 megohms. So it's pretty darn leaky. So anyway, when they come in, I'll get these all rebuilt and new resistors on here and stuff. And I went ahead and I put it back in, but I come over here and I also replaced a couple resistors here. Let me line you down here and see if I can kind of pull that in a little closer. Angle's not the best, but replaced 3 resistors here. I pulled this can out, and on these 3 of these IFs, they've got traps on them, and basically what they are is just a coil and a capacitor, and that's it for the traps. And they're shown in the schematic. Let's see, where am I at? Okay, here we go. Like this. They don't make no connection. Basically the way they work is they're adjusted to a particular resonant frequency, and when the signal's coming through, that frequency is also coming through, and I want to trap it out. So what it does, it'll see that resonant, and it'll try to start resonating this coil and capacitor. When it does, they produce a counter EMF and a counter field, which is set up with the proper number of turns, and everything is set up just right, so that basically will block that signal. It actually doesn't completely block it, but it attenuates it considerably. Just that one signal where these adjusted at for the frequency that they're resonating at. And that's how they work. So they don't need no connections whatsoever. So they're the only things that's in the cans that's got mica caps in them, and they're exposed. I pulled this one out to get it out where I could look at it, and that one there, I could not see it's got a plastic base. It's pretty clear. There's no discoloration to the plates at all. They're nice and shiny. So I'm, for the time being, I'll make an assumption that the other 2 that's got those are probably just fine too. If in alignment they don't seem to want to adjust to a null, basically you're looking for pulling that needle down to a lower value, and it should peak or come down to a null where it's low as it'll go, and then it'll start rising again. If I can't get them to do that, then I'll look at replacing those caps. But these are the types. It's got a plastic base. They've got a rivet through. You've got to drill the rivet out. The plastic that these bases are made out of is rather fragile. With age, it becomes somewhat brittle. So it's a tedious and slow process of drilling those out. If you get, if it catches or anything while you're drilling it, it could actually just shatter that base. So anyway, I went ahead and put it back in and replaced the resistors. Every one of these were out of tolerance. I'll be checking the rest of these. Now, that brings up something that's kind of interesting, a point that, we'll back up here a little bit. If you go to the forums and you read, back posts and everything, you read them enough over the past few years, or at least since they've been pretty much there, and they still got a lot of posts, you'll find time and time again people talking about the restoration projects and stuff, and they run into, on several restoration projects, they kind of start running into trends about resistors, what's out of tolerance. Some of them will have, like, high value resistors will be more commonly out of tolerance, like, anything above, say, I don't know, 10K, 50K or something. But when they get above a certain value, a high value, most of those seem to be out of tolerance, but the low values always check really good for at least most of them. And other guys will be saying that it's quite the opposite to them. My experience has been that if you're in this and do this enough years, yeah, you'll see those trends kind of come and go. But overall, over the period of time of decades, they average out. The only thing, if I wanted to pinpoint a particular resistor that you might want to at least check a little bit, or when you're doing your spot checks, is cathode resistors. They got the full tube current going through them, and I don't know what percentage, but a little bit above average, those I find bad out tolerance. It's not a lot. It's not, like a real big deal, but it's enough that I would suggest that you check those anyway. And they're usually pretty easy to check, so you don't have to normally have to pull them out of the circuit or anything. So, but that's the ones, if there's anything that's kind of tipping the balance to being a problem, is the cathode. Any resistor on the cathode on any tube. Now, due to the fact that I've had a couple little problems, but not really anything to really complain about. But I'm seeing more and more people either with videos or people writing in on forums, these domino caps, the micas, are starting to show leakage, showing being bad more and more, like this one. Now this has 5 of them in it, and I don't have any of the values, so I decided to just go ahead and order them. I think all 5 is under $10. I decided just to order all 5, and that way, and I will be checking these just to be sure that they're not leaky. But I think the deal is they're getting old enough now that some of them are starting to leak through the case here and getting some air in there, some oxygen in there, and with a little humidity and moisture, that the silver's starting to corrode. I don't think it's actually to the point where, geez, you might as well just shotgun them. But I think it's enough now that you might want to be prepared to at least test them. Check them. So, something like an ICO model 950B, there's several different, and they're pretty reasonable on eBay. Capacitor leakage testers, well, they check capacitance and leakage. But it might be something that you want to think about. Excuse me. I pulled the tuner out. There's some resistors bad in it. I took it apart and checked them. There's a couple 3 in there that are bad. But I ran into something quite interesting when I did. I got all the parts stored up, but here's the tuner. Right here, the drum. Now, these drums are held in place with a spring clip on each end that goes from here to here, and sits underneath these hooks and pushes this down. There should be one on each end. You can see the hooks are there, but when I look at them real close, and I also look at this shaft, now yeah, there's some markings on there, but you got to remember there's another shaft that goes over this, and that's where the marking comes from for the fine tuning. There was no spring clip here. And when I look really, really, really close, magnifying underneath here where it would hook, and also looking at the shaft, there's no markings that there ever was a clip there. So I think they kind of forgot to put it in. Now, that's supposed to hold it down. What was holding it down is there's a washer that goes on here. It sits down here, and then there's a spring-loaded metal piece that goes on, and then your shaft that goes on here for your fine-tuning. And a spring-loaded shaft with the washer keeps that a little tension on that, so it's not free turning really. In other words, you turn it to set the fine-tuning, it stays. Well, that little washer fits down underneath these two tabs here. So that was it's still loose, but it kept it good enough that it would work all right. Now I pull this out, and well, that's the insides. But the bad thing is the resistor is down below here. That's the guy that's one of them that's out of tolerance, way out of tolerance. Trying to think, I believe it's this one here that's the other one. They had a side cover on here. They actually had it screwed and soldered down in a couple places. So I just unsoldered it and took screws out. Because you've got some resistors in here that you want to check. And I'm not sure, see this was cut off. It goes to the back panel, you know, the back cover for the TV. And of course that's where you hook your antenna on. Well, someone decided that it would be a good idea just to cut it instead of unsoldering it. And I think they cut enough off of it that this length may be a little tight. But I've got some of this twin lead, so I might go ahead and just replace it. Make sure I got plenty of length. Okay, see. I don't really have much else to tell you except for one other thing. Here, I don't know, been 2 or 3 years back, I was watching one of Bob's videos, or B. Anderson TV. I think it was on him restoring his gray bar, I think it's a gray bar radio, old TRF radio that basically uses a RCA chassis in it and stuff. Anyway, it was badly rusty, and when he took the power socket unit out, or the power supply out, tried getting it out, all the bolts twisted off. Because it just, I mean, they were rusted pretty much almost through anyway. Well, he came up with the idea that the nuts were rivet nuts. They make certain type of nuts they'll rivet on, and that way they stay in place. And they were brass, and so he was going to cut them off, but I think, you know, he went checking for cut off wheels or whatever, and he came up with, they came out something new, and he was talking about it. I think it was on those videos. He can correct me if I was wrong, but it's these little cut off wheels. They're a lot better than the older style, which had just a small little hole, a little mandrel that came up. They had a screw in it and you screwed them on. These things are really much better. They're quick release mandrel in them. You can get a kit, and you just pull that and turn it, lift it off, and put it back together. Hold on, we have a phone call. I'll be right back. Alright, we're back. That was my daughter on the phone. Anyway, you know, it's a nice quick set release mandrel. You know, the kit comes with like 2 or 3 blades in the mandrel, and then you can buy blades by themselves. You can kind of see I've wore this one down some. I've cut a lot of stuff with it. But that isn't what I want to talk about as much as that, yeah, I cut a lot of stuff with it. Bob shows on their demonstration of it cutting just a general standard screw that is probably not a real hardened screw. Well, I needed to make a tool, and for these type of set screws, they're called slab set screws, or slab sets, because the head is just like a slab, a flattened piece of metal. You see this in a lot of these old radios and turntables and stuff. This happened to be on a turntable. So a lot of times you can get in there if they're not really super tight with a pair of needle nose pliers and break them loose. But this one happened to be in a place that you couldn't get nothing in. So I realized I needed to make a tool for it. Well, I wanted to make it out of something good, you know, so it'd last. So I had this file. Now this is a file. What this is a file for a chainsaw to sharpen the chain. And these are really high quality steel, tool steel, to stay nice and sharp. This one's quite old and pretty much worn out. I still use it around here on other things like some aluminum or something like that. But I took that Dremel, I don't know if you can see it, but I cut. I had to make 2 cuts and then kind of grind it on each side a little bit to get it exact, to make the tool for this. Now this is hardened steel, and it cut through it with no problem at all. So those wheels, the thing I wanted to talk about was the fact that those wheels are excellent. It didn't really basically wear it down much. In fact, I actually measured it before I started cutting it, and it didn't hardly take anything off of it. Not enough that I could even, you know, use just a regular ruler to judge. But it was 2 straight cuts down, and then what I ended up doing was, since this blade is just a little narrow, doing that, it wouldn't make it quite wide enough. Then I started shoving it each way there, kind of keeping it even, and grinding a little bit on the surface. So I wanted to point that out. They're really high quality cutoff wheels. I mean, they cost a little money, but they last and last and last a long time. You can cut a lot of stuff with them, and you can, I mean, when you can cut something like this, it probably took me, you know, when I started grinding at the sides, you know, I didn't want to get overzealous with it, so that took a little longer because I was just doing a little bit at a time and then check it in a little bit of time. But the actual 2 main cuts, I don't know, a minute maybe tops, probably more closer to about 45 seconds to cut that down. So the darn things are really, really good at cutting and lasting. So just thought I'd point that out. I think that's about all I got for you right now. I will continue with this. When the parts come in, I'll do another video and show, you know, what I ordered and what came in and stuff and everything and what we'll be doing. So in any case, I guess I'll see you guys in the next video. If you like this video, give it a big thumbs up. I thank my new subscribers. Some of them have said, have commented on the channel, and they were quite kind words, so I thank you for that. And if you happen to come across this video, and you're not a subscriber, please subscribe. That way you'll get notifications when each video comes out. So anyway, I'll see you guys on the next video, and you have a good day, the rest of the day. Thanks again for watching.